Hey everybody, we're live here. We had a little technical difficulty on the getting the X Live posted. I don't know, they must have had one of their regions must be having some sort of traffic issue. Um, but let me create this broadcast here and post it. Okay. Okay, nice. All right, cool. Looks like we're live on Twitch, YouTube, and X. So another live stream today, guys. Vibe coding live stream. We're going to be focused on the Blue Cactus Agents refactor. Let's just go to my X profile. Little strange behavior on X today, but let me see. Okay, cool. Yeah, see that. Let me delete this one. Delete our old these old live streams here. Cool. Nice. Let me go to YouTube real quick. And by the way, guys, I just want to thank everyone that has liked and subscribed so far. It means a lot. I think we're up to 344 subscribers now, so that's pretty big. We're definitely seem to be getting some momentum, and so I'm happy with that. Let's just get let's get this YouTube live that we just ended. Let's delete that real quick. Let's go to content. Okay, yeah, let's delete this one. All right, so delete. Okay. Okay, cool. Do it. Let me see if I can do it on Twitch now. Just deleting the old live stream here. Let me see. Let's go to home. Channel on Twitch. See if we can do this. Let's go to videos and okay, this one's live. See if we can figure out how to delete this one. Just right back. I'm gonna see if we can get the X live stream working. Okay, let's delete. There we go. Okay. All right, cool. So we deleted that last live stream. That's 5-minute live stream where we're having some technical difficulty. So anyways, today we're going to be going through this agents refactor. So in the past I've went, and let me just open up this, let's see, OpenAI voice API. Let's see. Yeah, so in the past, I was I built out this agents architecture in a chained style, right? So what does that mean? Let me come down to chained here. So here's a chained architecture. So I'm integrated with Twilio to handle phone calls. So that's handling the transportation of the audio over the cell network. And then we had a speech-to-text model. And we're going to find out which one I had been using. Let's see. Just open up a new agent. I'm going to say, yeah, I'll let you to review the current architecture. At one point, we were using... Ooh, let's get my whisper flow. At one point, we had built out the chained architecture and using all of the microservices. We had each service split up into a different microservice. Now we brought everything into the Cactus Hotline service. But I want you to review all of my services and let me know what we're using for speech-to-text and text-to-speech and the generative stuff, which models we're using. I forget exactly what we're using. So let's get that going here. Hey everybody, so we have this plan here, guys. We're going to be rebuilding the agent's business architecture. So right now I'm just doing a review of the existing system. And so pretty much we're going to be moving from this chained architecture over to this speech-to-speech, or at least we're going to bring this voice layer over to this speech-to-speech real-time architecture. And let me post in the Discord here. Let's get this open. Let's see. Okay. So let's get to the Discord and copy the video URL. Cool. Okay, cool. So today, guys, we're going to be using Gemini 3.1 Pro until we hit some sort of limitation. If we hit a limitation, we'll switch to Opus 4.6. So anyways, we're going to be switching over to this speech-to-speech real-time architecture, or we're going to start working on that. So here you can see these are my existing services, and we can actually pull them up in Ghosty here too. And guys, this is just a directory here, right? When I do ls, it lists out all of the services inside of the directory. And let's see here. So DeepGram. So I did have a dedicated endpoint. So at one point, and it's been a while since I've worked on this, guys, so just walking through this, but so at one point I had a DeepGram endpoint in one of my services. I'm assuming it's the Cactus transcriber service. And so we have a dedicated endpoint called call DeepGram transcript that would receive the live transcripts and then process them as speech, right? Then we're using this Twilio gather to capture user audio during the call. So we're using pretty much DeepGram. At one point, we had one microservice, and we were using DeepGram to just handle the audio from the phone calls. So pretty much we'd pipe in that audio using the Twilio integration, and then DeepGram would help us convert that speech to text. Now, I forget the exact DeepGram pricing, but let's check it out. Let's see if we can. They give you $200 of credit for free. Then it's probably usage after that. Let's also ask, let's see if we can pull up ChatGPT here. Okay. Let's go. Let's say, give me the DeepGram pricing. Okay, let's see. So they give you the $200 free credit when you sign up. And then speech to text pricing. There you go. So about 50 cents an hour, which is not terrible. It all depends what type of business you have, right? And how many minutes, or what your usage is. And that's all variable depending on the business type. But that doesn't seem terribly expensive. Maybe it wasn't DeepGram that was the expensive option. But we'll look into DeepGram. We also have Assembly. Here we go, text to speech. So we've got AWS Poly. So we were using via Twilio. So we're actually using a Twilio text to speech model. That was pretty fast. So it's actually Amazon built this speech to text model called Poly. And I guess Twilio was helping serve it for us. So here's the generative stuff. I'm gonna say, okay, now I think we're using the fast route in the hotline service. Can you review the flow of that and let me know which models we're using in that flow? At one point we were using 11 labs for text to speech, and it was pretty natural. While I'm doing this, what I can do too is I'm gonna have Codex. Let's copy the path from this plan here. I'm gonna bring up Codex. Let's open up another session here. And I'm gonna say, I want you to review this plan and give me your thoughts. Do not make any code changes yet. We're migrating to the OpenAI real-time API and making other major changes to the system design. Review closely and give me your thoughts. Again, do not make any code changes yet. Okay, so we're gonna have in the Codex app, we're gonna start having it review this cursor plan. Okay, let's see here. Okay, here's the fast route. The fast route is heavily optimized to reduce latency and make the conversation feel more natural. Okay. So we got the immediate latency hiding. So this is where we're using, so at one point, the latency was so bad, and that was partly because we were using HTTP protocol to hop between many different microservices, and that was all adding to the latency. So at some point, just when I was playing around, I introduced like an office chair squeaking, maybe some ambient sound in the background that sounded like an office, but it ended up just kind of sounding like a call center or something. And that's when I just kind of walked away from the voice agent, because it felt like it was very robotic and had a lot of latency. But now that the models are more intelligent now, we're going to see if we can refactor this using the OpenAI real-time API and also doing a major system redesign. So So here we have, when the caller is hearing the thinking sound, the server asynchronously processes their speech in 3 phases. Okay, it uses OpenAI function calling to extract structured data. So this is one mistake I made too, was this intent classification. So I was using an embedding model from GPT, and there's other open source options for embedding models that are free. But I was using an embedding model actually when I was ingesting some of that speech. I would take that text and tokenize it using this embedding model and then do a similarity search. But what I've learned is that really for the orchestration at the voice layer, we really need to be doing tool calling. And the model's intelligent enough. So now the OpenAI real-time API does the speech to text and the text to speech and the tool calling all inside of one model. And so that's one optimization that we're going to make. Let's say, okay, but in the fast route, what model were we using for a speech to text? And one thing I did too, guys, is we're going to be taking, reviewing a kind of how LangGraph, how LangChain, how OpenClaw handles orchestration. It's a very similar, from what I understand, very similar pattern of this multi-agent orchestration and also this RAG orchestration. And so we're going to review some of these patterns that have become popular for managing multi-agent orchestration. And we're going to take some of those learnings into this project here with us. So let's see. The fast route, you're using Twilio's default native speech recognition. Okay. Okay, so walk me through each service. Be very concise. Describe what each existing service is doing, and the models that we're using. And review the Git log. I want you to review the Git log history, because at one point in time, we had not migrated everything into the hotline service. We were using all of these microservices, but now we're not using them. And I understand that, but I want you to walk me through all of the different microservices when we were using these different microservices in the flow, and describe which model we're using in each of them, what they do, and then also describe how the fast flow works now after we migrated all of this functionality into the hotline service. I want you to describe how the hotline service works as well, and be very, very concise. Do not make any code changes. Oh, hey, thanks for the follow. Thanks, Wit. Appreciate that. Let's see. Hey guys, it may not be the most exciting or the most glamorous stream today, and we may not even work on any front end stuff, but for now we're going to be doing really focusing on this system design. Also, if you're new to the stream, I do a little bit of old school RuneScape, just AFK skill grinding in the background. while the agents work, just chopping down some trees. At some point, we're going to maybe build a plugin. So RuneScape has this open source framework called RuneLite, where you can build plugins on top of it in Java. So that may be a fun project we'll do at some point. Let's see here. And while that runs, guys, so really, let's see if we can find phase 1 here. So after we review this a bit more, we're going to end up deploying phase 1 of this plan. So we're going to build out the core services, and then we're going to migrate to OpenAI real-time API. And here's the core path here, which we're going to have this voice edge, the media stream gateway. We may want to combine these two services here. Then we have an inference gateway and this dialogue graph, and this is where we're going to be uploading our business documentation. And then we're going to have an agent trace service that's going to use the cursor protocol, or any standard protocol that we can use for agent tracing. Because these models do hallucinate a lot, especially in a business context, for a business workflow. When you first deploy them in the wild, there's going to be hallucination, and it's critical that we understand this hallucination, or why it hallucinated, and how we can, or steps we can take to prevent it from hallucinating. So let's see here. So here's the past architecture. So we had Cactus Transcriber, received raw audio streams from Twilio via WebSockets and forwarded them to Deepgram for real-time speech-to-text transcription. Okay, so so here's the transcriber service, and then here we have Cactus Intent. So this would take the Twilio audio stream using Deepgram and start converting that from speech to text. And I think what I ended up doing, at one point I was using Deepgram and 11 Labs, OpenAI for the generative stuff, and Twilio. And that's when there was a lot of like hopping between microservice to microservice, right? And every one of those hops added some additional latency. And that's when I moved everything into the hotline service, more of like a monolith. And then I started using the Twilio models, right? So this is when, instead of streaming audio to Deepgram, I was using Twilio's native gather verb. And Twilio was actually sending that transcribed text to me. And so that was faster. Letting Twilio handle that was actually faster than passing it to another service and letting Deepgram do the transcription. So that's why I did that. Now we might end up moving back to Deepgram, but we'll figure that out. And then we have the Cactus Intent, right? So this is where we receive the, and here's that service, Cactus Intent. And this is where we receive the transcribed text. So this was actually Cactus Transcriber would pass that text or make a HTTP call, right, over the HTTP protocol and pass that text to the intent service, right? So let's see. Receive the transcribed text and used OpenAI's GPT-4o Mini to classify the user's intent and generate the text of the AI's response. So then we had Cactus text-to-speech, right? So after we classified the user's intent in the intent service, we received the generated text and converted it to audio. And so the text-to-speech service was using 11 labs. And we're going to actually... Okay, tell me the pricing for 11 labs. We're building out voice agents. It's important for me to understand the pricing for DeepGram and 11 labs. And give me some examples of use cases, different business types, and how many phone minutes those business types have. Okay, let's see. Sometimes oh, here we go. Okay. So here's 11 labs. So like for $100 a month, you get 500 minutes of text-to-speech. Even 2,000 minutes of text-to-speech is not a ton. For 1,000 characters via API business tier levels. Okay, like here's a SaaS business with AI phone support, right? So you can imagine one of the primary use cases is support. So here it says, so 200 hours of phone calls, right? That's 12,000 minutes with customers. So that's $1,300 a month, right? Which you know, if you think about it, that's super expensive, right? Or at least it seems to be. I haven't really, I need to crunch the numbers. I'm kind of sharpen the pencil. But you know, it depends what sort of license or what your pricing model is. You know, I'm probably thinking like a base fee. And then that includes some usage, and then any usage outside of that would be like metered billing. But it doesn't seem like a ton of minutes. I need to think about this more. I won't go too deep into this now. Okay, I'm building an agents business, and we're going to be serving all different types of SMB businesses. Give me more examples. This 11 Labs pricing seems a bit pricey. Give me your thoughts. For voice agents, okay. So the business, you get 13,000 minutes. what that means in real terms. Yeah, so this is not even considering the Twilio cost, right, for the phone calls, plus any OpenAI cost when we're using the OpenAI real-time API. So let's see. So here's like a virtual receptionist, and I'm just walking through some of this pricing, and then we'll get back to the system design, because I can always swap in different models easily. So let's see. And you got to think, this is just a single business, right? Yeah, but the scale plan only gives 3,600 minutes, right? So once we hit this limit, all minutes outside of this limit will be charged overage per minute, right? Yeah, but why this is concerning is a single customer could hit these limits, right? Yeah, hey, Acarine. So really that's like semantics. I think vibe coding and coding with agents, maybe they're not exactly the same, right? It depends how you're using them. So I guess vibe coding traditionally is more like, I'm not reviewing every single line of the code, right? Coding with agents, I know some traditional engineers that keep it in ask mode always, right? They never move it into agent mode. So they keep it in ask mode, and they'll never let the agent run commands or modify the code, right? It's more like using the agent as a consultant to communicate with the agent. So coding with agents, I guess, could have it could mean, hey, I'm just consulting with the agent and then I'm writing the code myself. So I can see how those two terms can be a bit different and have different meanings. And the monthly cost. So for me, I'm on the Ultra plan of Cursor. I have ChatGPT Plus, so I'm also using Codex, right, in ChatGPT Plus. And actually, for $20, OpenAI is giving an incredible amount of Codex usage. So really, I'm primarily using Cursor. A Cursor, you can kind of rip through the credits pretty quickly. So I'm paying $200 for Cursor Ultra, and then I'm paying $40 for BugBot. So I'm getting PR review from OpenAI through Codex, and so I'm getting that for $20, and then I'm getting a BugBot PR review from Cursor. That's $40, and then $200 for the Ultra plan. Now, if I'm kind of ripping and running every day nonstop, you can eat through those credits pretty quickly. But hopefully that answered your question. But let's come back to Cursor here. So, and then we had the Cactus Agents service, right? So we had Cactus Agents and handled complex multi-step tasks like calendar booking. It utilized the OpenAI Assistance API, specifically using OpenAI GPT-4 to manage conversation state and trigger function calls. Okay. So then we had Cactus SMS, which was a utility service that handled sending outbound text messages via Twilio. for calendar links and confirmations. And then we had this Cactus Gate service. So when I built out this architecture, which was the chained architecture, right? So if you're familiar with this chained architecture from OpenAI, so a chained architecture processes audio sequentially, converting audio to text, generating intelligent responses using large language models. If you're new to building voice agents, both the user input and model's response are in text. Control what happens in your app. Turn an existing LLM-based application into a voice agent. Speech-to-speech architecture. So here's a guide for building the speech-to-speech architecture. So as latency is critical in voice agent use cases, the real-time API provides 2 latency transport methods. Then we've got the speech-to-speech, right? The multimodal speech-to-speech architecture directly processes audio inputs and outputs, handling speech in real time in a single multimodal model, right? So this model, the model thinks and responds in speech. It doesn't rely on a transcript of the user's input. It hears the emotion and intent, filters out noise, and responds directly in speech. So I'm going to say, let's see. So definitely, you know, once we bring this product to market, you know, understanding our cost, right? Our cost from if we use DeepGram, if we use what service we're using for speech to text, what service we're using for text to speech. And we may be able to knock all this out with this new OpenAI real-time API, and that might be able to reduce cost a lot. And we're going to find out. But you know, we won't go too much deeper into this. Now I'm going to ask, explain how the new OpenAI real-time API works. Explain how the tool calling works and how you define the tools. Keep this very high level and concise. Okay, so low latency bidirectional voice. Your app initiates a real-time session, usually connection. Okay, so it's using WebSockets. So let's see, I thought we were using WebSockets, but I want to say we're not. So here's the current architecture. So speech to text, and I'm gonna turn down the chili. And guys, please like, subscribe, and follow if you haven't already. It helps a lot. It's really powerful. Been working with real-time and mini on a project. 1.5 is a nice upgrade. Hey, Danny. Hope you're doing good. Yeah, so that's what I'm working on right now, is redesigning the system design. So I have this whole enterprise refactor plan, moving to the OpenAI real-time API. And then I'm going to build an MCP server from this agent's business, and we're going to expose some of these agent tools to the telematics video business. And then we're going to try to deploy voice agents and SMS agents and chat agents in the telematics video business. And try to kind of build the agents for telematics video first. and focus on that vertical, but make it as modular as we can, so we can serve other verticals, eventually serve other verticals. Yeah, so what's real time? That's a good question. I guess it's not technically real time, right? Still going through the network. But so here's how my current architecture works. So instead of streaming audio from Deepgram, I was actually using the Twilio native Gather, right, which was using Google speech to text under the hood. So this was my big mistake here, is I was trying to embed text as I was ingesting that text, and then do some similarity search to try to map intent, right? And that was incredibly slow. Just embedding every sentence as it was coming in, or tokenizing every sentence as it was coming in, was not the right approach. So now, as we ingest that audio, the OpenAI real-time API is going to determine the intent and then make the tool call for us. And this should improve the latency a lot. Hey, Winpo. Yeah, so today I'm refactoring the agents business. So I had built out a chained architecture in the past, where I was ingesting user audio, and then I was using Deepgram for speech to text, then doing I had an agent orchestration service that was doing tool calling, and it was integrated with Google Calendar and SMS. Then I was using 11 Labs for text-to-speech, and all of that was integrated with Twilio. And it just felt very robotic, and there was too much latency. So today, we're going to be doing a pretty big refactor and migrating to our voice layer to the real-time API. And let me see if I can go up here and find my different services. Let's see. Okay, so here are like the different services. Let's see. Let's just put up some text. Let's go see if we can find our to-do. Okay, let's just open this. And let's put this in here. Okay, so here's the architecture. List out all the services. Services, again, very concise. Let's see if we can get this to put it in a big text here. Gemini. So I could just kind of read it off from here. So pretty much, okay, here we go. See if the stream can see this. And guys, a lot of people, with vibe coding, right? Just the system design is obviously critical. But let's see. No. Okay, I wanted you to tell me, we had decided if we were going to use EC2, try to run on spot instances, or do the event architecture for each service. Make sure to include that in the list. Okay, let's see. So pretty much, I'm pretty much walking through all of these services. So we're gonna have one service that handles pretty much the Twilio ingress, right? And so I got to look into exactly how I did this in the past. Was I in the architecture now? Are we using Twilio WebSockets or no? So here's kind of my design, right? So we've got all of this is going to get deployed on Kubernetes, right? So we've got the voice edge high noon, and they all kind of have like Western theme. So I've got the voice service, right? And I might end up combining both of these services here. And both of these are going to be on-demand services, so they need to be highly available, right? So it's not like a service where I'm going to have some serverless Lambda functions or something, or it's like event-driven architecture. Sagas? No, Winpo, but you always give great suggestions, and I will look at that. Right now, what I was going to do is I'm looking at, and I may end up using LangChain. I know I've heard of LangChain. I'm reviewing LangGraph for some of my RAG orchestration and see how they're handling some of that orchestration. But I am building out the RAG orchestration. So I've got these two services. These are going to be on the EC2 nodes that are running 24/7 and on demand, highly available. Maybe not bursty, right? Just highly available. Then we've got this service, right, which is the real-time routing and tool calls, right? And maybe even, I need to think about this, but maybe even all three of these services could get combined here. And really what I don't want is I don't want a bunch of hops, right, from one microservice to the other, because every single one of these hops adds latency. Then I've got this, the dialog graph. So this is a orchestration state machine, right? Then we've got the low latency RAG query. And I don't know why it's suggesting a spot instance for this, because to me, if it's a RAG query that's happening in real time, that I would assume that would need to be on some highly available server, that the CPU and memory are available at all times, so it can be quick, right? Here we go. This is an interesting one. So the indexer, right? So this is the service where, and this might be overkill with too many services, and we're going to think through this, but this is the service where when I do upload the documents, right? This is a service where it's going to use some embedding model to tokenize that PDF or that business document. And so, maybe this job, if I'm a company and I'm just setting up the tool and I load up my documents for the first time, maybe this is a service that could run on spot instances, right, in the background. So that's the thinking behind that. Let me see. So then we've got the booking orchestrator, right? So this is going to be the booking workflow. So this is where we're going to fetch like calendar availability. And depending on what the business workflow is, we're going to have some sort of booking orchestration, right, that can hook into your calendars. I got to think about this too. Maybe this is not the best service to have as a spot. Then we've got, so this is for SMS. Here's our authentication service that we built in Go, right? Here's our front end. And this is we're going to build out like a tracing tool to handle agent validation and agent traces, right? And Cursor just released a protocol for agent traces, and we're going to build out a tool kind of similar to Sentry, where we're using some sort of protocol. I think one of the protocol names is OTel, to help us trace all of the tool calling and every step that the agent made along the way. And what I already know that, each vertical is going to have its own unique hallucinations, right? And I know for certain that when you deploy these agents for simple business workflows, that there's going to be challenges, right? And I'm going to have to go find early adopters or companies that probably can accept like a 70% success rate, right? And be willing to work with me as we deal with the hallucinations one by one. Yeah, so gRPC, I know that is faster, right, than HTTP protocol. So yes, Winpo. Oh, hey, Midnight Simon. Thanks everyone for joining. Yeah, I can cut down the tree. I'm cutting it down. So, and hey Simon, we just got rated on Twitch, guys. This is I'm building out an agent's business. And these guys, this is the architecture or the system design. And a lot of people would be probably reluctant to show the system design, right? Because everyone says the hardest part about vibe coding is building out the system. And so I'm just kind of walking through how I'm thinking about building this system. So, and one thing I'm doing is agent tracing. So Cursor actually released a protocol, Cursor tracing protocol. Let's see. Is this it? Yeah, so one thing that we're going to integrate into our agents business, because I already know that, and guys, I'm in the telematics video business too. So if you've ever seen any of the other streams, I work with like dash cameras in the vehicle and companies that have vehicles that are out on the road. And so we're building out this agents business, but the first vertical that we're going to be targeting is telematics video or fleet management, right? Just because that's a business that I'm familiar with. So the idea is that we're going to take, we're going to try to deploy voice agents, SMS agent, chat agents into my telematics video business for support, maybe for some basic discovery sales stuff. Also when we get certain events in the system, or maybe we see a pattern of events, we reach out to the customer maybe with a voice agent and also an SMS to give them some sort of alert. And if they want to have conversation with the agent, they can do that. So one very important thing is I already know that each vertical that you try to deploy agents into, each one of these verticals is going to have its own unique hallucinations. Yeah, okay. So let's go drop this wood off real quick. I have someone reminding me. And guys, while we're live streaming or while we let the agents work, I like to just chop down some wood in old school RuneScape. One of the coolest parts about old school RuneScape is there's this open source framework called RuneLite. And it's pretty amazing, but I guess some engineer at some point took RuneScape, old school RuneScape had deployed their game, right? And I guess it was a jar file. And I can never pronounce this word, but some engineer took that jar file, and I guess it's called de-obfuscating or something. I can't pronounce that, but pretty much, I guess the jar file had all method names that were really not human readable method names. But this engineer was able to reverse engineer it. He ended up building this framework called RuneLite, put it on top of the game. At first, I guess old school RuneScape really they were resisting this open source framework, and eventually they just went ahead and adopted it. So now if you ever want to deploy like plugins, you end up deploying them on top of RuneLite. So it's pretty It's pretty cool. So they have this whole entire plugin ecosystem. And what's pretty sweet is each one of these plugins, you know, you can go to that GitHub repository and review the code and maybe try to make a contribution. And so, you know, right now I'm just kind of chopping wood, but eventually that something we maybe want to do is build a plugin if people are interested. But anyway, so we're going to be using this new Cursor agent trace protocol, right? Where, and it's going to be similar to Sentry, where when we deploy these agents into different verticals, you know, we're going to use this protocol to trace everything the agent did as it was trying to work through this simple business workflow, and then use this information to help us resolve hallucinations, pretty much. And guys, if you're not, since we have a bunch of people on Twitch too, you know, we're working on the agents business, but this business is a lot more mature. This is the telematics video business. So we have dash cameras and vehicles, and this is 3JS, which is a 3D map on top of Google Maps. So we do mapping. We have a dash camera in the vehicle. We do geozones, right? So anytime vehicles enter, exit geozones, we can send you an arrive or depart. We have, we're doing geospatial stuff in Postgres. So instead of like doing this at the application layer, and every time we get a latitude and longitude that's inside the geofence or outside the geofence, and doing some math at the application layer, actually Postgres is doing that for us. At the database layer, which is pretty cool. And we're using Redis to help us do this, and this is all real time. And that I've always said it has the as indeed obfuscation. Yeah. Thanks, Fluffy. Thank you that helping me phonetically spell it, I guess, right, is how you'd say that. So this is a geofence, right? And really what I want to show you guys while people are in here, but I built a new PDF. So now when I look at the PDF for any one of these events, we really made some major improvements to the PDF. So now what I'm doing is I have all new heuristics. So I've taken all of my signals and I've normalized them between 0 and 1. And then I'm using that to try to build some sort of score, right? So like in this scenario, the score was low. This is not a good one. Let's see if we can get a better one here. Okay, this one was high. So here it said, like, pretty much goes through the video. I'm using object detection and depth estimation. Then we find the most relevant frame, right? And pretty much we take that relevant frame and we're passing it to a vision model, right? And we're using the pretty much our different normalization signals to try to help us determine which frame is important or not important. And then we take that frame and we're passing it to a vision model. So like here it was able to see like a person is sitting in the driver's seat of the car holding a cell phone up to their ear with their right hand. The person's wearing a hoodie and a seatbelt. The interior of the car is visible, including the front passenger seat and back seat. So I was able to tell, okay, I detected a phone. Then we're building like an action plan, right? So we've got an action plan for the driver, telling them, hey, you need to put the phone in the glove box. Then here are some driver reflection questions. And the idea is that you sit down with your driver and then you, the driver puts a signature and the coach would put a signature, and it's just like an acknowledgement saying, hey, we know there's an event, we're just reviewing it together. But anyways, the idea is we're taking the agent's business, we're going to build out the agent's business, build out the MCP server, expose tools to this product here. And so this product's going to be using the agents, and so we're going to deploy the agents into this product, right? And so like here's kind of an interesting one. This one was just sitting at a stoplight, and so the vision model was able to determine like, hey, this image shows that you're at a traffic at a intersection, right? So like in this one, I was on my phone, but I was standing still at a stoplight, and so it was able to determine the driver is focused on the phone, which can significantly distract from driving, but the car appears stationary or parked, right? So it's able to do that reasoning and make that determination, like, hey, this guy is actually just sitting still. Yes, Fluffy, the Minecraft modding days. I didn't play a ton of Minecraft. Kind of grew up on Halo 2, really, and then RuneScape. Eventually started playing some World of Warcraft, but didn't go super deep into WoW. Not the most hardcore gamer, but you know, it gives the nostalgic vibes for sure. Okay, so back over here. So, this is essentially the system that I'm about to try to build, right? So I'm going from kind of this architecture. So in the past, I had a transcriber service that would ingest the audio from Twilio. Now let's make sure the stream can see this. So I had a transcriber service that would ingest that raw audio from Twilio, and then I would forward it to this service called Cactus Transcriber that was using DeepGram for the real-time speech-to-text transcription. Then we had the intent service that was using GPT-4o Mini to classify the user's intent. Then I had my text-to-speech service, right? Then I had the agent service that was helping me with orchestration, and an SMS service, and then an API service. That had a ton of latency. I ended up migrating, instead of like using DeepGram and 11 Labs, with both DeepGram and 11 Labs can get pricey, I ended up using these Twilio native speech-to-text and text-to-speech. And that improved the latency a lot, but still had like a ton of latency, to the point where I didn't even feel confident even wanting to talk to my customers about voice agents. And so now we're building out this plan, and we're about to start working on this plan. So like, here's my scope and constraints. So like, first thing is we got to de-slop it, right? We got to keep the code minimal and readable. Remove unnecessary hops. So I've even read somewhere that like, if latency is critical, maybe even build it as a monolith. You know, I'd prefer to build it as a multi-repo microservice system if possible. But we'll keep thinking about that. So we're going to deliver this core call path first. So we've got, and let's pull up our different services. So we've got the Voice Edge service and the Media Stream Gateway. And first I'm going to ask Gemini, does it look like any of these, we can combine any of these services? I really want to eliminate unnecessary hops between services. And WinPo, you know, I have thought about using gRPC. And what we're going to do, guys, too, is we're going to take this plan. I'm going to build out different issues for this plan, and then we're going to use the GitHub MCP to push these issues to the organization, so we can just get those issues up there, and then we'll start working through this. Hey guys, thank you everyone who's here and watching. I appreciate it. Please like and subscribe and follow if you haven't already. It does help kind of push this content out to more people. So let's keep looking through this. So this is the core path that we're gonna build out first. Yes, absolutely. You have great intuition here. Look, it's being nice to me. Looking at the architecture with a strict de-slop and eliminate hops lens, we have heavily over-fragmented the real-time path in some of the back-end workers. Right, so you can see here that, like, I have a few services here, like this voice service, plus this service, the real-time audio bridge, plus this tool calling service. I'm almost thinking all three of these services could get combined. Let's see. So yes, absolutely. You have great intuition here. Looking at the architecture with a strict de-slop and eliminate hops lens, we have heavily over-fragmented the real-time path in some of the back-end workers. Here are the specific places we should consider to eliminate network hops. And guys, so network hops, like, what does that mean? And I know there's some people that are technical, some people are not so technical, but really, like, if I build out these different services, and if you look on the right hand side, you can see each one of these services is like in a different directory. And I'll just show you, like in my current Kubernetes setup, right? I have all of these different services. So this is for my telematics video business. But you have all of these different services, right? And pretty much every time, like, you have to take data and move it from one service to the other, that's like a network hop, right? Now, in this case, if the services are inside of my cluster or inside of my environment, you know, that's not, there won't be as much latency making that network hop versus if you like made a network hop to some service that's on the other side of the world, right? But still, every single network hop that you do make adds some additional latency. And I don't know if WinPo's still here, but he brought up using gRPC. And I do know that moving data, I guess gRPC, I think I understand that it's it serializes the data into binary and moves that data between microservices using binary. Now I need to think about, in this use case, you know, will when those services, you know, just serializing that data into binary, is that going to add additional latency, right? Versus just passing it over the HTTP protocol. Yeah, so then I'm going to come back to cursor. I'm going to say, okay, great. Give me all of the services again, with the services that you decide to combine, or go ahead and give me the list of services, make a decision on which services that we can merge together. And then also let me know, is it a service that we can run on a spot instance? Is it more of an event-driven service that we should be using like Lambda serverless functions to handle that? Or is it a service that needs on-demand or constant availability on an EC2 server that's not bursty, that has CPU or memory available 24/7? So let's read this again. It says, let's see. Okay, yes, absolutely. You have great intuition. So the real-time voice path. So combining all three of these services, right, into one service. So that's going to eliminate a lot of hopping. So why OpenAI's real-time API uses a single WebSocket for both audio streaming and tool session events. Splitting audio, bridging, and inference routing into separate services forces us to sync live audio and JSON events across internal network hops. This is an architectural nightmare for latency. Okay, so that makes sense, right? Then we've got the RAG engine. So we've got these two services that are going to be our RAG engine. So this is where we're going to be uploading our business documentation and then tokenizing it, embedding it, and putting it into Postgres. So let's see. Okay. Business workflows. Okay, we're going to combine these. This is a node. So guys, my thinking right now too is any service that has business requirements where the business requirements will change often. I'm going to use like a node or TypeScript, right? And the reason is because there's this huge open source marketplace of packages, right? So it's easy with Node or TypeScript to, as you're getting, and this is my understanding after talking with AI, but as you're getting new business requirements or anything that's like control plane or any stuff I need to glue together, my plan is to use Node or TypeScript. Anything that's like a hot path service that needs to be highly available, I'm going to use Go, right? That's kind of the idea. Also, maybe any like background stuff that maybe gets launched on Spot instances, I may use Go as well. So, let's see. Okay, background cron jobs. So interesting. So these are all my constant availability services, right? You've got the voice service, you have the authentication service, you have the OTel, the tracing service, and you have the front end. Here are our Spot instance services. So we've got, here's like the LangGraph state machine, right? So this is what confuses me. These services are stateless, queue-driven. So, like, it confuses me why these services would go on Spot. So what confuses me a bit is if say I have a sales rep or a customer support rep that's using this agent, or the agent is reaching out to the end customer on its own. When it goes to retrieve these business documents, will the Spot instance work? Or, right, this needs to be very low latency, right? When we go retrieve these documents, or we do our similarity search to go retrieve the right documents to bring those documents into the context. Why would we put these on Spot instances? Help me understand that. Yeah, so here it's saying that all of these services can be deployed on Spot instances. So Spot instances pretty much are like 70% cheaper than a standard EC2 instance. And the idea is that AWS will give you these instances, but at any point they'll give you this 2-minute warning. They'll give you this 2-minute warning saying that they're going to go interrupt that workload and pretty much take that server away from you. And so your service has to be stateless and ready to deploy or schedule on a new server. And so I'm just trying to understand why the RAG service could maybe get deployed on Spot instances. Let's go. Okay. So let's see. Okay, again, so here are all of our Spot instance services. So we've got the graph runtime. We've got the docs engine. We've got the business workflows. You know, this one too. Here's a sandbox. So we're going to be using Firecracker to where when they do set up the business workflow, if they want to like execute some code at one of the turns, they can do that. Let's see, Liquid Glass backend, Mesa Glass, what it does. The backend API for your desktop Whales app. Okay. Event driven. And this one, I mean, this kind of makes sense, but we're going to ask it about that too. Okay, so here's like all these background jobs. So generating call summaries, exporting transcripts after the call hangs up. So maybe after the call hangs up, you know, there can be some delay in all of that data kind of loading into the platform. And so that might be able to be a background job, right? So pretty much what I think about is like, okay, what are the and I'm not an expert at system design, right? But this is just the way I think. But it's like, okay, well, what services are hot path, right? What services am I ingesting data? Is there a lot of data streaming in? And those services maybe have to stay on a server that is always available. And also AWS has some servers, and I don't remember exactly, but some of them are what they call like burstable, right? So you get an X amount of CPU or X amount of memory credits, and like if the service is not very consistent, and sometimes you have these very bursty moments, and sometimes not so bursty, right? So sometimes traffic's low, but on like an example would be AWS, I guess. Like on a Black Friday is probably a incredibly bursty day for them, right? Where they like on that day there's a ton of traffic, and so you need a server. Maybe you could save money by using this server that has burstable credits, but you don't use them all the time. You only use them when traffic is very high. So we'll see. So that's what I'm thinking about. It's like, okay, what's hot path? What needs to go on EC2? Always available. What services can get interrupted, right? If they can get interrupted, I can run them on spot instances. Which services are serverless? And so what's more of like an event-driven architecture, right? Where just an event happens and I send it to some Lambda function that executes, and I just pay for that on more of an event-driven type of style. And guys, I know it's not the most glamorous, exciting stream day probably, but if anyone has questions, please just let me know. And please like and subscribe and follow, guys. It does help a lot. We're about to start going through this plan, or having the AI just see if we can one-shot this thing. Okay. Okay. You are 100% right to question this, and that is a fantastic catch in the spot tier. Okay. These services also don't look like they should be in the spot tier. Can you review all the services again, and then give me the list of all services, which ones will be on spot instances, which ones will be event-driven, and which ones will be on highly available EC2 servers. Okay, so here we go. So here's our EC2. We've got OTel, the front end, the authentication service, the liquid glass service, the workflows. The workflow service. Front end, then we have OTel. Yeah, so this looks good. Then we got spot instances. Agent validation, trail judge. Here's this this code execution. Yeah, this probably needs to move on demand. Yeah, I think that this needs to move on demand. Also, let me know if each service is CPU bound or memory bound. And also let me know what you think if any of these services are hot path. Okay, got it. Moving the firecracker makes total sense. Okay, here's the final consolidated list with the 13 core services. A hot path, blocks a live phone call or UI click. Okay. So this is one thing I've been thinking about, the LLM really helps me get smarter about this to even ask the right questions, but I'm also thinking about, okay, is the service CPU bound, right? Is it like, does it need to be blocking on the CPU? I'm going to say, okay, good. Also add, does it need to be blocking on the CPU or asynchronous non-blocking? Or give me your thoughts. Give me the full list again, very concise. Let's go through this. And then what we're going to do is, after this, we're going to go maybe, we might pull down OpenClaw, kind of look through LangGraph, LangChain, OpenClaw, think about multi-agent orchestration, or think about how they're handling orchestration a little bit, and then try to take some of those learnings, keep working on this plan, right? So here's the final highly concise list. Okay. So highly available EC2. So this is our voice layer, right? This is the voice layer. So this is what we're going to call a hot path, right? And it's network CPU bound, which is kind of interesting. I thought it would have been memory bound. Concurrency. Async non-blocking. Nice. So this is where we're going to be using Go routines. So I guess this is CPU bound, which is interesting. So then we got the dialog graph runtime. This is going to be a node. Then we have, and this is memory bound. This is memory and CPU bound, mixed. Async non-blocking for PG vector searches. CPU blocking when parsing / chunking large PDFs locally. Right, so that's interesting. Is we'll actually, I guess, open up a thread on the CPU and do a blocking operation, right, while we handle this. And still kind of, when I think about CPU bound versus network bound, my head still kind of does a little bit of a twirl. I'm just gonna say. Can you just give a little bit more detail about blocking versus non-blocking and how it uses the operating system threads? But be very, very concise. I'm on stream and I wanna give a little bit of an understanding to my audience. Okay, let's see. Okay. I wanted you to give me the description next to each service. List out all the services again. So it's 13 total microservices, guys. So let's see. Okay. Yeah, but you left out the descriptions of the service. So I want the description of the service, if it's memory or CPU bound or both, and then a description of why we're doing async or non-blocking, and how that language will use the operating system threads, and why you made that decision. Be very concise. Okay, so here we go. So here's our voice layer. So you have the single real-time bridge, receives that Twilio WebSocket, opens the OpenAI real-time WebSocket, and handles the tool routing, right? So this is network I/O and CPU. So the network I/O is going to be, and I think network I/O is using memory, right? So, and then I'm going to have it suggest a service too. I'm going to say, okay, great, give this to me again. Okay, great, give this to me again. But also let me know which service will be using Postgres, which service needs to use Redis. And which AWS server you would suggest for each service. Okay, this service is maybe at the beginning might only be serving 1 or 2 customers, so we don't need massive servers. We want to start small. I'm familiar with EC2 and the T3 servers, but do this again, but consider that I really want to optimize for cost, and we want to start small. Okay, so I guess we'll maybe use all burstable servers for now. So here you go. So we've got the voice layer here. So this is the real-time bridge using the OpenAI real-time WebSocket, right? You've got network I/O and CPU, async non-blocking. So we're going to use Go to do this. It's going to be using Go routines. Redis. So we'll probably run that on a small bursty AWS server. Here we've got the LangGraph state machine. So this would be a single threaded event loop, which is interesting. So Node actually has one thread, but if you use asynchronous non-blocking, it never blocks the event loop. That's my understanding. And let's see. Now look at that. So Node.js does kind of use a little bit, just at baseline, it uses more memory utilization than Go. So the Go binary is a little more lightweight, actually. Then we've got, let's see. Then here's our docs engine, right? So this is memory and CPU. It's going to be asynchronous and then CPU blocking. So I guess we will spin up a thread. The operating system, or Go, will help spin up a thread on the CPU, and that operation will be blocking. Now, I think in Go, it's not actually a one-to-one mapping of the operating system thread. So even though it's blocking in the Go runtime or in the Go environment, it's not actually blocking the CPU thread on the metal. But this is good. So looking. spends 99% of its time sleeping. Okay. CPU blocking. Okay. That's our service where we execute code. Then we have this liquid glass service. That's the liquid glass app we've been working on. Here's Go. Here's the front end. Here's Otel. Here's our spot instance services. Here's AWS Lambda. So this is some validation service where we're going to actually simulate like customer scenarios and run those against our agent. But here we have this event-driven architecture here. So then we have this is going to handle any like cron jobs or background stuff. I'm not even sure. We may need to knock out this service. I don't know what that one does. Listens to DB outbox, pushes to event bridge. Let's see. Okay, I'm not exactly sure what these 3 services are for. Do you think we can delay these for now? Okay, got it. So now I'm going to have it start updating the plan, right? So I'm going to say, okay, now that we've worked together to merge these services and give some more description of what each service is, can you review this plan and update it? I want to be very delicate with the way that we do this. I want you to break it out into different phases in the plan and what we should do for each phase. For now, everything is going to be running locally. We're not going to be setting up any Lambda functions yet or deploying on AWS EKS yet. So I want to get something working locally. Go ahead and update the plan. Do not make any modifications or changes to any of the services or code yet. We are just building the plan and brainstorming together. All right, let's see if let's see if Gemini can do this. I don't like I can't see the diff now on the plan. Like I can't see the diff, the actual diff here. It's okay, I guess, but it's kind of annoying. Okay, here we go. Okay, so here's the scope. Phase 0. Execution phases, okay. So core. Okay, review the entire plan again and see if we can simplify it at all without removing any critical information. The plan's a little, kind of a little complex here, so I'm going to see if we can simplify it a bit. Yeah, it feels like there's redundancy. It attempted an edit, but wasn't able to do it. Hey guys, I'll be right back. I'm gonna get a little top off on the coffee. Okay, I'm back. Okay, let's see here. Okay, so core scope and guardrails. There we go. Looks more simple. Single go bridge. Keep code minimal, no extra hop, sanitization, or abstractions beyond strict contracts. Build and test locally with ngrok and homebrew. There we go. 0 AWS infra until stabilization. Do not break existing Twilio flow. Liquid Glass Worktree current S3 CloudFront website. Build new ops UI. Refactor legacy tux into using cursor agent trace standard. So phase one in the LangGraph integration. So let's make sure, guys, LangGraph has an MIT license, I believe, but we're gonna double check here. So it does have an MIT license, which is good. Okay, so here are our phases. Okay. Post-core auth integration slice. Let's see. Okay. Existing debug front-end reference. Got it. Okay, agent validation platform. Yeah, pretty much we want to keep all of the existing directories or the existing services, and all of these new services will be new directories that we will create. Eventually, we'll add a remote origin on GitHub and set up a repository, but for now, we're just going to create the directories and test locally. Okay. I think it kind of knows that already from what I've read, but so guys, here's kind of the here's the flow right here. So this is kind of what I'm looking at here. If anyone has questions, you can ask the questions. You know, this system design stuff, you know, is kind of complicated, especially the architecture. Now, if you guys are vibe coders and you're just trying to get a product out there, right? I wouldn't suggest kind of doing what I'm doing now, where I'm really deeply thinking about system architecture. You know, I would just focus on a prototype and making sure any sensitive information secure and just getting it into a customer's hands, because a lot of this stuff, you know, if you're able to get customers, you can hire people to help you with all this stuff, right? You know, like if you get customers and you get enough traffic to where you're having some sort of scalability issue, you know, that's like a good problem to have. And you know, with the money that you have from the services you're selling, you can use that money to hire help, right? Or come back and refactor it yourself later when you have to. Right now, I'm really just trying to get it set up from the start to be scalable, so I don't have to think about it moving forward. But you know, if I was like needed to get dollars in my bank account yesterday, you know, I probably would just get a working demo, right? Something that just a front end up, and I could go call someone and start demoing it to anybody that's willing to listen, right? So anyways, let's keep looking through this. Okay. Are you ready to plan mode and start executing phase one? I think we're going to, guys. Let's read through this one more time, guys, and then we're gonna execute this bad boy. So, okay, so we got 10 hops on the hot path, right? We're gonna migrate to OpenAI real-time API. Keep the code minimal, no extra hops, right? Local first. We're gonna build locally. Do not delete or overwrite existing services. So all these existing services, I don't want to touch them right now. Do not break the existing Twilio flow, Liquid Glass Worktree, or current S3 website. So we do have a website right now. It's not on AWS EKS. I just have it hosted on S3 with CloudFront in front of it. And I just don't want to touch that right now. We're going to build a new front end. So we're going to build a new front end with Next.js and TanStack Query. I've never used TanStack Query, but I know it's kind of like the new hot thing, so I'm going to try it. If anyone has used TanStack Query in here, let me know what your thoughts are on it. Then I have a service called Tux, which we can go into in a bit, but pretty much it's a CLI tool that I've used in the past to create like customer simulations, right? So the idea is that I have a customer that sets up the simple business workflow, and then I use a service to simulate customer interactions, and then we trace it using observability, is the idea. So here's phase 1, phase 2, where we're gonna add the RAG, phase 3, telemetry, OTel, OTel to tempo. What is this? That's good. What's this? What is this? Not familiar with that. What is this? Okay, so we're going to be using LangChain, right? We're going to be integrating that code. We're probably going to go pull in OpenClaw in here just so it can have a reference. Got it. So it's gonna LangGraph's gonna be helping us with the tool calling, right? Then what we're gonna do too, guys, is we're gonna pull down OpenClaw. Let's see, OpenClaw, GitHub. And now OpenClaw, I'm just gonna say, okay, can you clone this into a directory? I could probably just do it myself. Okay, so I just cloned OpenClaw. Now, created by Uber. Open source distributed tracing system created by Uber. It tracks requests as they flow through services and shows you latency, spans, and dependencies. Okay, we'll leave it in for now. Let's say. Okay, in this plan, can you include to take design concepts or design patterns from this directory poly and use that same sort of design pattern, but keep our professional Western blue cactus theme? So I have another project I've worked in the past called Poly. One day I'll show that to you guys. It was like a tool for local municipalities or local state governments. Anyway, so I just want to kind of use some of those design patterns or the way that we built that out. Use that as reference. Also add to the plan that we want to use Tailwind. Okay. Okay, then what else? We have this micro. What is SG Lang? Explain what SG Lang is to me and other tools that are similar. What are other tools in the market that are similar? I'm building an agent's business, and I'm interested in maybe open source tools that can help us, that has some sort of key value, cache, or attention mechanism that we can learn from. Okay, so that's actually LangChain. So are we using LangChain or LangGraph? Okay, so I'm going to be using the OpenAI real-time API. So what open source framework could maybe help us with managing attention and storing cache? We're using Redis, or storing key values or preferences, I guess. Managing the context. We're looking for frameworks to help us manage this context. We're already using LangGraph. Which one of these frameworks has an MIT license on it? Includes, okay. Okay, in a very, very concise way, just in a raw text string, tell me all the tools that we just looked into and what they do and why we're thinking about using them. For now, we probably don't need this, but I might add it here. I'm just gonna say, what we're gonna do is I'm gonna say, okay, so I'm considering like a key value cache framework that we can clone into this directory, Blue Cactus AI directory, and learn from, or possibly integrate for our attention layer. Give me your thoughts on this. I want to keep phase one incredibly simple if we can. Give me your thoughts on these different options and which one you think we should consider. Don't make changes to the plan yet. Just give me your thoughts. Yeah, so especially if we ever migrate to like using open source models at some point, which probably not now, but you know, this KV caching, key value caching, is incredibly important. Interesting. So OpenAI is completely abstracting the KV cache away from you. Caching right now to save money and speed up the non-voice parts of your system. You already have this. It's perfect for exactly what you noticed. Text-based chat or background, but terrible for live voice. Keep phase one incredibly simple. Okay. Okay, that's fine. Let's see. So, okay, I did clone in OpenClaw, and I want to add to the plan that I want to just review the OpenClaw code and review how they handle multi-agent orchestration, and just take some learnings from this. We don't want to use this code right now, or bring over any of the exact code blocks. We just want to review the patterns and the design decisions and take learning from that. We're almost there, guys. We're gonna start cranking on this plan pretty soon. Just want to make sure that you know, the plan is solid here. Okay, let's kind of read through this plan. Okay, so we got 10 services, right? Ask ChatGPT. Is there any other? Is there any other frameworks that we should be considering for an agent's system design? Here's AutoGen, yeah. Mem0, I've heard of this. Okay, what about these? Guardrails AI? Here's OpenTelemetry. Pretty much, guys, any of these that have an open source license that I think we could take some learnings from the code, we're going to be bringing it in. And we might, if it has the right license on it, like for instance, Lang graph, we might use that for our RAG orchestration or tool calling orchestration. Cool. Okay. Let's see. Lang fuse. So I might be going a little overkill here, guys, but let's see what Gemini thinks. Okay, what about any of these frameworks? Could we use or implement any of these frameworks, or should we clone any of these repositories into this directory so we can review the code and take learnings or review the design patterns? Give me your thoughts. Again, I want to keep these phases as simple as possible, but I'm interested in any frameworks that we can use that will add value. And guys, please like and subscribe and follow if you haven't already. Mem0 memory management. Interesting. Okay. So we're going to pull down Llama Index, Mem0, and Open Telemetry. Okay, should we just clone the Open Telemetry repository too? Can you clone all of these into this directory? Okay. Okay, we just clone these repositories down, guys. And let's get a different some different music on, guys. Hold on. Okay. Okay, update the plan to make sure that we reference these repositories that we cloned and take learnings from these repositories as we work through these phases. I've heard good things about Mem0. I don't know if any of you guys have used any of these Mem0 if anyone's played with OpenClaw, any open telemetry stuff, LangGraph, LangChain, Llama Index. If anyone's worked with any of these, let me know. I'd like to hear your thoughts on it. And feel free, guys, ask me any question you want. I'm very open. Dropping off our wood here. Okay. Okay. All right, guys. I think we're gonna start going through this. You know, I think we're good enough now to phase one. Let's go. Intents, become real-time tool calls, conversational intents, intent to tool matrix. Slice, okay. Okay, begin the slice after phase one. Front end branch policy. Yeah, make sure that you have in the plan that we integrate our Cactus Auth Go service. You might see two existing authentication services, but the one that we want to integrate and continue to use is the Cactus Auth Go authentication service that we wrote in Go. What I might actually do, guys, too, is maybe create some issues right now. Okay, you know what? We're probably gonna just move forward here. We don't have much to lose here. If there's any major problems, we can always go backwards. So I'm gonna say, okay, let's go ahead and start executing the plan. I guess we could come here, Gemini 3.1 Pro, and then let's build this thing. All right, guys, so we're going through the build now. Gemini 3.1 Pro. Nice. I had all my working trees were clean, which is good. Conditioning down here. Okay, it's adding these services right now. It's adding some controllers or some like request endpoints, it looks like. It's interesting. It's actually just adding the code right from the terminal with the terminal command. Hold on, guys. I'll be right back. I'm going to use the restroom. Okay, I'm back. Let's see. So it looks like we're going in, adding all these different services and setting up just some handlers or like some controllers, some endpoints so the different services can communicate with each other. Let's see. Yeah, just setting up some basic controllers, setting up the directories. Go to the to-dos. Interesting. Hold on. It didn't just do phase 1. I may just let it go through the entire plan. It's kind of interesting, but okay, I thought we were just going to go through phase 1 at first, but it looks like the to-dos are not doing that. I should have taken a closer look probably at the to-dos, but that's okay. Let's see what it added so far. So it added all of these services here. I'm assuming this is some WebSocket from a Go WebSocket. Hold on, can you Can you fix the to-dos to go along with our phase 1, phase 2, phase 3, phase 4 plan? It doesn't seem like the to-dos were adhering to this plan. I wanted to be very delicate with this. I'm not sure if it's going to be able to do this now. Let's see. Here's the plan you need to modify. I may actually create a new plan and delete all of these directories that we just created and then start over. But we'll see. We'll see if Gemini can figure it out here. Okay, here we go. All right, let's just let it rip and run here. So we've created all of these directories right now. So we're going through these phases right now. So it looks like it's working on integrating the existing Cactus Auth Go service to secure the new endpoints. Let's see, what is this? This is modifying the main file. I think we may be able to almost ready to even try it. But let's see. So voice edge high noon. I'm gonna make sure it's not still calling this old service. I don't want it to call the old service. Okay, help me understand why you're mapping those old routes first before we move forward. I'm gonna have to create new ngrok tunnels and update them anyways. Okay, I'm gonna have to create new ngrok webhook tunnels and update these routes anyway. Yes, we want to use this current front end to debug and we want to make a call as soon as we can. But these routes, if you want to change the route names, you can do that. But I guess if you keep the routes with the same endpoint path, then I guess we just start the new services and not the old existing services. And if we start the new services, those endpoints will stand up with those paths and the front end will work as expected. Is that your thoughts? And guys, if you have any questions, you can feel free to ask me. Right now, I'm rebuilding the agent system design. All right, cool. So guys, again, this is let me see if I can show this is kind of what we're building right now. If anyone has any questions about my system design, you can ask me. So I really did think through this in some good detail, and now we're just moving through the plan here. Just make sure, guys, I don't have any important emails. Okay, let's see. So it's really like setting up, it's going through every single service, and then it's standing up API endpoints, right? So it's kind of just like boilerplate endpoints, right, for each service. And then some like 200, what the response status is, or the response message when those API calls are successful, and then the error handling. So very basic. It's pretty much going through each service and adding some very basic boilerplate controller endpoints. So let's see everything that we added so far. What service is this? This is the graph runtime. We're probably gonna have to create some new tables. Okay, this is where we're setting up the new front end with Next.js and TanStack query. What is this? This is okay, here's the front end. Interesting. So here's the hotel collector using tempo. Honestly, I like the Western themes, but sometimes, you know, I see like Trail Boss, and I'm like, what the heck is Trail Boss? Okay, let's see this. You know, I should have worked, you know, I got a little antsy, but I should have made sure my to-dos, you know, I did phase 1 first, then phase 2, then phase 3. And it kind of did that, but really my idea was I wanted to do phase 1, test, make sure it's working, phase 2, test, make sure it's working, phase 3, test, make sure it's working, and then continue moving on. I didn't do that, but that's okay. Okay. It's really just setting up the scaffolding for all of these services, these new services. So here are all the new services that we've added so far. And guys, if you haven't already, please like and subscribe and follow. It does help kind of get this content out to more people. And it means a lot. So here's like the agent trace record. So you can see here's the interface. Here we're going to be inserting it into a new table. We're going to have to create these new tables once we're done with this. Here's my liquid glass back end. Huh, look at that. When I highlight some items here, and then I adjust this, it starts moving the highlight. Huh. If I come like this, moves the highlight. Look at that. It moves the highlight location up. Huh. Interesting. Here's Firecracker, what we're going to use to execute code in a sandbox. Okay. Okay, I think it did it. Okay, great. Yeah, we can stand up the old debug front end, and stand up the new voice service with the same port, so it will talk to it. But a quick question: I have, how is this authentication going to work? So we'll fire up the Cactus Auth Go service, and I'll authenticate, and Google will return the access token and refresh token. But how will are these wired up yet? Is the authentication service wired up to the other services, or how will this work? And how is the intents going to work in the OpenAI real-time service? You log in. Web. Yeah, but the current front end doesn't even have a login screen right now. Okay. Okay, so review the start dev bash shell file, and review the start ngrok bash shell file. I think we're gonna have to spin up the ngrok tunnels, and then you're gonna have to give me the Twilio webhook endpoints, and I'll have to log into Twilio and go add them. Yeah, but the ngrok tunnel changes every time, so I'm still gonna have to update the webhook in Twilio. Does that make sense? Okay. Okay, so what should we do first? I might have to move this off the screen while we generate this endpoint. I gotta get my other phone number. Hold on. Let's see. Let's get this phone number. 2 2. Okay, I found this number. Cool. I want to make sure we only call this number. Human. So guys, I got some sensitive information on the other screen here. Yeah, or I thought I just enter in the number that we're going to call from the debug front end. Why are you hard coding it? We should be able to enter it from the front end, right? AI has a tendency to add fallbacks everywhere, I've noticed. I've noticed that for a while, but okay, so do we go ahead and start the ngrok tunnels now? Okay, guys, we're about to start these ngrok tunnels. I'm going to log into Twilio. We're going to set up our webhook endpoints in Twilio. And then we're going to try to make a phone call here. Let me enter in this. Okay. All right, let me do this off screen. Okay, go ahead and start the ngrok tunnels and then give me the Twilio webhooks. All right, starting up these ngrok tunnels. I'm in Twilio. As soon as I get these So guys, we're standing up these ngrok tunnels. The ngrok tunnels are so we can, from local, the ngrok tunnel is so we can, and I just don't want to show the ngrok tunnels. No, you can go ahead and try and kill ngrok. Do it. There we go. Worked that time. Okay. Okay, so I got my ngrok Twilio endpoints. Let's go ahead and add them. Hold on. Let's go to voice, manage. Manage. Where are my phone numbers? Hold on. Phone numbers. There we go. Manage. Active numbers. Click the number. Okay, let me add these webhooks. A call comes in. These look a lot longer than usual, which is interesting. Say, what about this one? Status. What about this one? Bear with me, guys. I'm just setting up these. I just don't want to show these ngrok tunnels on stream. Okay. SMS webhook. There we go. SMS webhook. Okay. Call status changes. Okay. Get this in here. Call status. And then let's get this one right here. Okay. Just save them in Twilio. Send some screenshots. Oop. I don't know what you guys can do with these tunnels, but take another screenshot. Okay. Okay, this is how I set up the tunnels. Does this look accurate? The endpoints for the ngrok like look longer. It's weird. Okay, ready to test. Okay, great. Let's go ahead and start the services and then we can test. After you start the services, give me the endpoint, the localhost endpoint, so I can open it up in the browser. Hey, run a local so you don't have to deal with ngrok. Yeah. Well, even if I run the local K8s cluster, won't I still have to like, will Twilio won't talk to my endpoint if it's on localhost, right? I always get confused because that's why I do a lot of testing in the cloud, because I have tons of microservices and they're all making these network calls. And I have other partners that have servers that they're sending my system data. And so I always thought that I had to have the endpoint in the cloud to kind of ingest that data, if that makes sense. But thank you, Winpo, for the suggestion. I'll definitely look into that. Okay, so let's kill these. Okay, looks like it's starting up. Yeah, so Twilio, whenever it pretty much sends webhooks with the audio, and also when there's status changes in the phone call, and also for SMS. So yeah, they're like Twilio webhooks, exactly. So like when a message comes in from Twilio, pretty much it fires a webhook to this endpoint that I have standing up. And I won't share the entire ngrok URL, but it looks something like this. I don't know if you can see that, but yeah, so it pretty much messages come in and it fires it to this webhook. And also this. Yeah, so kind of ooh. Yeah, exactly. So it fires this hook. So let's see here. You can go ahead and start the front end. Do it. Nice. Okay. Let's see, Cactus Web. I'm sure it's on. Okay, so I think you just started up the index file that I have hosted on AWS S3. I don't think that's the debug front end. Are you sure that's the debug front end? Huh. Oh, I didn't merge it. There we go. Okay, we did it. All right. So now we're gonna open up the logs. Or let's kill this and start it again. Okay. Okay, so I'm about to make the test call. Can you open up the backend logs so we can follow them together? Let's see. Why is it? It's just trying to grep the file. Huh. It's like grepping through the sections of the document one at a time, which is kind of interesting. I don't know why I decided it needed to do that. Like, it's literally grepping the word test call. Why doesn't it just use the browser tool to just take screenshots? Or just read the code? Or what is it trying to do? What is it doing? I'm actually curious what it's going to say when it's done with this. And guys, please follow, like, and subscribe if you haven't already. It does help push the content to more people, and it means a lot. You know, trying to build a community here of people that like technology. I'm gonna put my Discord in the chat. put it in. If any of you guys are interested in joining the Discord, I put the link in the chat. If you just open that up in your browser, I don't know why I keep look at Gemini. It's like grepping every single keyword in the file. I'm just curious what its goal is here. Almost feels like it's in a loop there. John Doe. It's interesting. Just want to know what the end game is here. Let's go. While we wait for Gemini to work through this, we'll okay. You know what? We're probably gonna. Why are you grepping all of these keywords? What's your goal? We're about to. Okay, I've located the backend logs. They're actively running and waiting for the call. Okay. Here's the backend logs. Wait, is this the... does this terminal have an ID? Can you open up another terminal and follow the logs? What annoys me a little bit is like sometimes when I want to follow these logs, it'll open it up in a background terminal that I really can't see. I want to say that it's weird that I can't see this command up here, but I just want to follow along in the logs when I go make this test call is really the plan. Okay, I think this is it. We're just gonna go try. Okay, so let's open this up here. All right, so I'm actually gonna go enter my phone number over here. I want to do it off stream. Let's go find the phone number. Okay, let's try this. 69. Okay. We're getting errors in the console. I wish I had the Chrome MCP server set up right now, but I don't. It's not hitting the right endpoint. Oh, I think I did the wrong one. Hold on. Wait, I think I clicked start test conversation instead of the phone call button. Hold on. Oh, I made the phone call button. Oh, here's the phone call. It's coming in.
Error has occurred. Goodbye.
Okay, So we got an application error. What I have to do now, usually when I hear that message, it's like a Twilio problem, right? So I'm going to go into Twilio now, the Twilio console, and I'm going to go to... Okay, so, and I don't want to show you, I think we have the webhooks wrong, but I hope someone doesn't like hack me here. But pretty much now I'm looking at the post request got a 404. So something's wrong here. I think the ngrok URLs looked way longer than they should have been. We got a Twilio error. Are you sure you have the ngrok URLs are accurate? They felt way longer than they are normally. If someone gets a hold of my ngrok tunnel, what can they do? I mean, I'm not too concerned about that. We're incorrect. Okay. Okay, give me all of the webhook endpoints. I need all of them. There's one for status and one for SMS too. Okay. So these are the same as they were before? Do I even need to update them, or you just added to the environment file and then restarted the services, right? Okay. You know, if anyone tries to mess with my ngrok tunnels, I'll figure it out pretty quick. Okay. Yeah, but that's the same tunnel I added before. Hold on. Let's go back to Twilio. Hold on. Guys, if I'm missing any chats right now, sorry about that, but let's see. We're getting close here. Let's go to configure. Okay, yeah, I think they're good. Okay, so are you following the logs? Okay, is the front end up or did you kill it? I can't get to the debug page. Okay, there we go. Okay, here's the log. Okay, now I can go ahead and come back over here. And we're about to make a phone call. All right, let's see if this works. Okay. Okay, let's make this phone call. Okay, I'm getting the phone call. Hello? Testing, testing, testing. Okay, I'm on the phone call now. I got Twilio to make the outbound call. I answered, and the agent is not saying anything. Testing, testing. Oh, here we go. OpenAI real-time API did connect. It initiated the outbound call. I'm curious of what happened. It made this change. Because the model doesn't speak until it hears you speak. Okay. Okay, so did you open and follow the logs? And guys, please follow, like, and subscribe if you haven't already. Right now, we're working on an agent's business. I'm trying to integrate Twilio, making an outbound call with Twilio, and connecting to the OpenAI real-time API. So let's do this again. Okay, I think you need to restart the front end again. I can't get to the debug page. And guys, if you haven't already, please follow, like, and subscribe. It helps push the content out to more people. And if you're interested in joining a community, you can join discord.bluecactus.ai. Just paste that into your browser, and it will take you to the Discord invite. There we go. Yep, nothing's running on port 3001. Okay, let's go there now. Okay, yeah, it's up now. So now let's get my phone number again. Okay, and you have the logs open and you're following them, correct? Okay. All right, let's make this call.
Application error had occurred. Goodbye.
Okay. Okay, I got an application error, but I don't see anything printing in the logs. I guess I need to check Twilio, right? All right, let's go check Twilio logs. All right, let's go look at the logs on Twilio. So let's go to active numbers, call logs. I think it forgot to put them in the environment file again. Can't find the API tunnels. Yeah, the endpoint was offline. Are you sure when you started the service that it pulled in those ngrok URLs from the environment file? It sources the environment file right there. Twilio thinks okay. Okay, and you have the logs open and you're following them? Okay, cool. It always forgets to start the front end. Hold on, you didn't start the front end. Front end is down. Nice. It's up now. Okay, now get my phone number again. Okay. Let's make this phone call. Okay.
You're sorry. An application error has occurred. Goodbye.
Something's still wrong. Let's see. Same problem. You must have something wrong. See if you can find those variables in the build. There it goes. You can't find it. Yeah. So this is the error message from Twilio. It's what's happening is the tunnel. I have it in my environment file, and it's like it's building the app, and it's not like sourcing the environment file. So the tunnel is not in the build or something. So when Twilio is making the call, it can't even find the endpoint, and so it's returning a 404. Wait, hold on. Why are you running start ngrok again? We can keep the same tunnel ID, right? You just need to start those backend services so they use the latest ngrok tunnels. Somehow the build doesn't have the latest ngrok tunnel. Actually, this is something that like I've noticed Opus is pretty good at this. Yeah, it is. It is in the .env. I don't know. Like it should be in this variable called server URL. There it goes. So it's right there. It's right here in the environment file. I guess see if you can grep those environment variables from the build now. It looks like it's about to tell me I'm right. Just trying to print it now. It's interesting because Gemini was able to do this because at one point I made a phone call and it went on for like 2 minutes with no error from Twilio. Oh, it just did it just.
Goodbye.
Super weird. Let's see if Opus. I kind of want to keep pushing with 3.1 Pro. No, same problem. It's still returning the 404 error. After the build sources the environment file and it builds with that environment file, can't you like do a cat or a grep just to see if that environment variable is in the build or not? Let me think. Back to Twilio. Let's go back to calls. It's like, let's let it keep rolling here. It's interesting because this call here, this was like a 2-minute call today, a 2-minute call, and it was calling this endpoint with a post with a 200 OK. So it has worked before. Gemini just can't figure out how to do it again. I see. Okay. It's pretty confident. It always forgets to start the front end too. Okay, you forgot to start the front end. If it can't get it, we might switch to Opus. Good. All right, cool. Maybe like the 4th time is the charm here. Okay, let's try and make this call now.
Sorry. An application error has occurred. Goodbye.
Twilio. Where's my Twilio endpoint? Oh. Okay, these are all the errors. This is like the easiest part. Should be the easiest part. It's testing it, and it's up. Yeah, why isn't this curl returning anything? Okay, yeah, just run start ngrok and then give me the new webhooks and I'll add them to Twilio. I'm gonna use the restroom, guys. I'll be right back. Okay, I'm back. Now, I don't know, should we kill any instances of ngrok or any ngrok processes first before we start this?
Where do we go when the sunshine meets the night? Chasing a ghost between the lines, stuck between the smoke and vice. Where do we go when the sunshine meets the night? Chasing a ghost between the lines, stuck between the smoke and vice. Where do we go?
You can run the kill command. Go ahead and do it.
Where do we go? Where do we go when the sunshine meets the night? Chasing a ghost between the lines, stuck between
Okay, here I am starting the Ngrok tunnels. I don't know, maybe the Ngrok tunnels died somehow.
When the sunshine meets the night, she's snuggles between the lines, stuck between the smoking vines.
Wait, what the hell? Hold on.
When the sunshine meets the night,
Oh, it's a little different.
she snuggles between the lines, stuck between the smoking vines. Where do we go? When the sunshine meets the night, she snuggles between the lines, stuck between the smoking vines. Where do we go?
Usually the Ngrok URLs are not that similar though, which is damn interesting.
Where do we go? When the sunshine meets the night, she snuggles between the lines,
Uh-oh. It looks like we hit the context limit.
smoking vines. Where do we?
Or maybe not. Okay, give me the exact Twilio webhooks that I need to go add.
Where do we go? When the sunshine meets the night,
Okay.
she snuggles between the lines, stuck between the smoking vines. Where do we go?
Okay, go into the phone number. Man, these webhook endpoints are so similar.
Where do we go?
Okay, I updated Twilio. Go ahead and start the services, the back end and the front end, and then hit the tunnels API to see if you can find the tunnels. Wait, what? Okay, I updated the Twilio webhooks in the Twilio console. Go ahead and start the services, and then hit the tunnels API to see if the tunnels are online. Okay, it hit the API. Okay, let's go back to our front end and let's make the phone call. Okay, and do you have the backend logs open, and are you following them? As soon as we find out if the logs are open and getting followed. Yeah, I think they are. They're right here and right here. Okay. Let's make this phone call. Okay. Here comes the phone call. Hi. Hello? Testing, testing, testing. Hello? Hello? Okay, we didn't get the error that time. Okay, nice. Now the tunnels are working, but when I answer the phone, the agent is not saying anything. Oh, shit. Yeah, I know. I just realized that, Winpo. I'm gonna go ahead and end the stream. I'll see you guys. Winpo, which secret got exposed? Did you see? What did you see? I need to change them all like ASAP. Was it just the I don't know how the hell that just happened. Hold on. Man, that's the problem with streaming. All right, yeah. All right, guys. Stream is ended today. I'll see you on the next stream. Thanks, Winpo. I'll see you on the next stream.